Good day, guys. Welcome to episode two of the series, Building a dApp and Cartesi using Rust. So, in the last episode, we talked about more of like an introduction to what Cartesi is, introduction to the series. We talked about the brief architecture of Cartesi, uh, things you should know why we do not Cartesi, like notice, vouchers, reports, input box, how user execution flow from a user to the base layer all the way to an attack on Cartesi through the node. So we talked about all those. The entirety of that tutorial of episode one basically was just to lay foundation on the remaining part of the series, which we'll be starting with today. So in today's episode, we are going to be doing more of like hands-on. So we're building a very simple dApp. If you remember from the last episode, we talked about a simple execution where Bob sends a message to dApp on Cartesi, and that dApp is able to just emit a notice that, okay, this is the number of messages we receive. So we are going to be coding that today using us. It's going to just be a coding session where you get to write out these codes and also test them out. So if you missed the previous episode, I'll advise that you go back and watch that video. We'll still be here waiting for you once you get back. So if you've done that, or if you watched the last episode, then we could. So I'll start with a brief, uh, just a brief talk about the necessary stuff, requirements, dependencies you need to get to be able to build on Cartesi. I'll walk you through the documentation, what you need to install. I might not be doing installations on my end because I already have those dependencies with CLI already installed on my end. But I'll just be showing you what you need. Then we'll go straight to bootstrapping it down, creating a folder, and actually building and testing out this application. So stay tuned. Let's get to the next section. Here, guys, this is the capacity documentation. I also drop a link to this in the description of this video. So this is a documentation basically. It contains this page contains all the necessary installations you need to make to be able to bootstrap and also build and capacity. So some of the very important things you need is you need to install Docker, you need to have Docker. So make sure you check the system compatibility and make sure you're able to comfortably um, run Docker on your system. Then the next thing to install is Cartesi system. So we have commands here, relatively terminal commands if you're not on this page of the documentation. You can visit this page, use this to install, run all the necessary installation, and get Docker and get the CLI running properly. So you have this command for Docker installation. You have this for Cartesi CLI installation. Once you have these two running, you can use the command Cartesi doctor to check and be sure that okay, you have all the necessary dependencies you need to run. So, for example, um, so I'll be running the Cartesi doctor command on my system just so you see a different idea of what it should look like if you have a system ready that's completely set up to run and build on Cartesi. So I just need to do my implement 15 and display this on the command. So once you get a reply or response like this saying your system is ready, it means you have Docker running and your system is ready to start building Cartesi. So what I'll do now, yeah, let's create a new project. So run the command to create a new project, which is Cartesi create. What I'm going to call that to hello world dash dash then create first. So once you do this, enter command. The Cartesi CLI is going to create a new folder for a source folder with Docker initialized and that's everything you need basically to build on Cartesi. So at that point, what you just need to do is just log into the application, then just start building basically. So let's see into our new project, Hello World. Then open this in Visual Studio Code or any comfortable editor of your choice. Once we have that up, the next thing we're going to do is we open our main.rs folder. So this folder. Basically, folder structure comes with cargo, src. That's where the main file is down. That's where you do most of your program. But you can also, if you're writing a very complex code, you can choose to have other files and import them into main, relate them to main into normal program, and you're good to do. So have targets, all these ones come basically with the bootstrap file, a folder. Then you have our Docker initialization here, and so one of the most important files here that I want you to take note of is the Docker file. Once the bootstrap Cartesi folder, it comes along with the folder. So it's basically the Docker container file for your entire project. So it contains the Cartesi machine, and it's the latest version of the Cartesi machine, and also in Linux VM. So what it basically does is, it once you build your program, your entire program is running on the current environment, and everything is already pre-configured in this file. You don't need to bother yourself about it. All you need to concern yourself with is writing your application. But be careful not to tamper with the content of this file if you do not fully understand what you're doing, because it could lead to issues like building or running the application. So we will go straight to the main.rs file, and three things I'd like you to take note of here at this point is we have three major functions here. One is the main function, the second handle inspect and handle advance. So the main function is like every regular Rust main function is entry points of your contract basically. So the main function is what runs. Then all these other functions, handle inspect, handle advance, and any other function you're going to be writing out while programming are going to be called inside your main function. So the main can trigger any other external functions that can trigger subsequent child functions and all the way down. So it's a regular main function. Then what will be new here is the handle inspect. Remember in our last video, I made mention of two ways to read data from your dApp on Cartesi. One is by calling the GraphQL server, and the second is by making a call directly to the node through the inspect API to get the state of the machine. So every call, or as a developer, every function you want to write out, every structure you want to write out is actually able to read data from your dApp will have to be going through the handle inspect function. So if one user to be able to query certain, for example, the list of messages on your dApp, you write a function or you write a logic to handle that inside the handle inspect. So look at it like a big function that's going to be handling all the read requests coming into this dApp. Then the handle advance is similar to the handle inspect. It's a function that's going to contain other smaller functions. But what it does basically is it handles advanced requests. So it handles requests that are going to modify the state of the machine. So every interaction that a user sends from the base layer through the input bus contract to the dApp is going to be hitting the handle advance function. So the handle advance function, you have to be smart enough to collect the payload, that's the data the user sent, decode this payload, and be able to discern the function or the execution the user is trying to run. So if a user is trying to modify the state of the Cartesi dApp, that function is going to, or that call is going to trigger the handle advance function. But if a user just wants to basically read states of the machine, get information about what's the current state of the machine, then those executions are going to be hitting the handle inspect function. So we'll be going straight to writing out our dApp, very simple dApp for to receive messages from users basically. So guys, at this point we have our handle advance and our handle inspect. So we're writing our logic in our handle advance function, just like we discussed. And the first thing I like to do is, first thing I like to do basically is to print the payload, so you get to see the payload in hex format. Then after which we convert our payload to a string, that's from hex to string, then initialize our payload in our dApp. The only thing we're doing here is basically just to convert that payload, to convert that payload to string. Then from string we'll console log it just to show that we receive this request from this user, and this is the request we receive. Then I'll go further to explain to you guys how to interact with your dApp that is running on Cartesi and the entire execution flow. So let's go. So guys, what I did here simply is in the first line, um, I'm converting the hex we received to a byte using the hex library. And the reason why I specified 2 is that we all know that byte starts with a 0 and an x prefix. And the hex library do not need the 0 and the x to convert your hex to a string basically. So what we need to do is we need to make sure we remove the zero and the x before sending uh, the hex value to this library to be converted. So that's why I'm using the two and the double dot there to remove out. As I'm saying, okay, submit every payload except the first two characters. And that's what we did here. Then the next line, we are converting the byte event we received to a string using the string method here. Then the next thing, the last thing we are doing is just to print out the payload we received from the user now that it's in string format. So we're moving on to test this stuff. For me, what I like to do is I like to space my terminal in two places so I can monitor the building and the interaction at the same time. So what we are going to do next is we are going to be building and running this Cartesi dApp. What building basically does is you run the command Cartesi build and it builds the Docker image, just like the word Cartesi build. It just builds up the Docker image. So it builds the Docker image that contains the Cartesi machine and it adds this code we just wrote out into the machine. So it adds that code into the machine and builds up the entire machine from the Docker image. Then what Cartesi run basically does is it starts up a local Anvil node. So from that local Anvil node, it deploys all the necessary on-chain contracts that the Cartesi infrastructure needs. So I'm talking about the MP bus contract, the portal contract, and also other contracts that you might not necessarily interact with as a user or are also very important for to the architecture of Cartesi. So but the major things you're going to be interacting with or playing with during the course of the series is the people's contract and also the portals. So it deploys all this on this local machine. Then it also deploys more very importantly our dApp contract. So let's go forward to building and also running. Also, it's important to note that running the Cartesi build and Cartesi run command might take a while, especially if it's your first time running it. So the Cartesi build command depends on your system resource and also on your internet connection to build your dApp. So you might have valid time frame for you to run the Cartesi build and Cartesi run command. But if you run into any error, it's important you read the error message properly, then check the documentation for any reference to that kind of an error message. If there's none or you still need clarity, you could always reach out to us on the Cartesi Discord channel and we'll be more than willing to help you out resolve your issue. So we're going straight up to running the Cartesi build and Cartesi run command. So how you interact with your dApp is by running the command Cartesi send generic. And the Cartesi CLI is going to ask you which network you want to interact with. Is it the Foundry, Arbitrum, or any Java network? So you specify in Foundry, the RPC URL, the mnemonic, and it's going to display to you a set of accounts you can use to interact with your dApp, basically like wallets that you can use to interact. And this wallet address are the same as those that RB gives you when you run a local RB node yourself. So if you're a Solidity developer and you run the default RB node on your local machine before, it gives you this set of private keys that you can use to interact with your dApp. It's the same set of private keys here too. So you can just select any of them to interact with your dApp with selecting this application address. Also, the application address is going to be the same address when you are building. So don't be surprised if you see same address every time you are building on local. So it's going to be the same because you're using deterministic deployments on local host. So you're getting the same wallet address every time you deploy into each other. But on mainnet or testnet, you're going to be getting a different wallet address for every dApp you are deploying. So we select string encoding because you are sending a string. The CLI converts that string to hex for us, then send it to our dApp. So let's say we want to send hello world from Bob. And at this point, this interaction is going through the local RB node, hitting the input bus contract, and node is listening to the input bus contract. It picks up that request, then it sends it to our dApp, and our dApp is able to execute a command. As you can see here, this is the execution in hex format. What we have here, OX2. And remember, we do not need the 0x when we are using our hex library. So we convert the 0, we cut out the 0x and send just from the 22, from the first 22 to the last 22. Send them to the hex library to be converted to string. And we can see here that at the end we have a nice message here. New message received, and the message is hello world from Bob. Guys, this is how you interact with your dApp on Cartesi when you are working locally. So you could either go through this route or you build out the front end and interact with your object dApp from your front end, whichever way you choose. But for the sake of this tutorial, we are just doing something very simple. So we are interacting with our dApp from the CLI, and so that this is how to write out a simple application, build, and also run. So in the next video, we are going to be building another dApp for Cartesi users. This is going to be a more advanced dApp. We're going to be building a calculator dApp. So we'll play with sending inputs now. Well structured inputs. It's not just going to be a string. You're going to be sending just an object containing the function we want to call, argument, send that to our dApp. Our dApp is going to be able to pick, decode the function we want to call, if it's addition, subtraction, division, and run the instance arguments. And we're also going to be moving a step further this time around. We are going to be interacting with notices. So stay tuned and see you in the next video. Stay rusty, guys.